Hey folks, welcome to Chapter 1, Lesson 8, Three-Dimensional Figures. Before we get into the lesson, let's do some bell work, which reviews key topics from Lesson 6, Two-Dimensional Figures. All right, you've seen this slide back in Lesson 6, and I want you to answer, fill in 6 blanks for me. 1, 2, 3, 4, 5, and the sixth one is actually the 12-gon right here, whatever that might be called. Okay, pause it, and then let's see how you did. All right. So, a blank polygon is a polygon in which all sides are congruent. That would be equilateral. A blank polygon is a polygon in which all angles are congruent. That's equiangular. This one's a little harder. A blank polygon that is both equilateral and equiangular is called a regular polygon. Okay? Regular polygon, you need equilateral and equiangular, but you also need the polygon to be convex. All right, what do you call a polygon of 4 sides? Quadrilateral. Polygon of 6 sides? Hexagon. And a polygon of 12 sides is going to be called a dodecagon. All right. A little more review from lesson 6. Find the perimeter or circumference and area of each figure. Go ahead and pause it and see how you can do. All right, so the first shape is a rectangle. So we know the perimeter is 2 lengths plus 2 heights, and the area is just length times height. For the circle, we know the circumference is 2 pi r, and the area is pi r squared. So the first thing you do is you write down the formulas. The second thing you do is you fill in the blanks, plug and chug. So we got plug and chug over here for the perimeter, and a final result of 10.6 centimeters. Perimeter is one-dimensional, so centimeters. Area, plug and chug, you get 6.72 centimeters squared. Area is always two-dimensional. It exists in R2. Circumference, plug and chug, you get 6 pi inches, which is approximately equal to 18.85 inches. One-dimensional perimeter is always in R1. And the area we get looks like 28.3 square inches. The area is always two-dimensional. It's in R2. All right, let's get on to it. Chapter 1, Lesson 8, Three-Dimensional Figures. All right, this is a solid with all flat surfaces that enclose a single region of space, and it is called a polyhedron. Each flat surface or face is a polygon. All right, how many faces do you see? You should see 6 rectangles, and the front and the back are hexagons. The 2 hexagons and 6 rectangles are 8 faces. The line segments where the face intersects are called edges. Notice the edges are line segments. How many edges do you see? An easy way to count them would be 1, 2, 3, 4, 5, 6. In the back, you got 1, 2, 3, 4, 5, 6, and then there's the 6 connecting edges for a total of 18. The point where 3 or more edges intersect is called a vertex. A vertex is basically like right here or right here. It's a point occurring here, like we might call a corner. Corner is not a technical term. We don't use that. And a vertex is not a corner. It's a point that occurs at a corner, right? So how many vertices do you see? Easy way to count them. 1, 2, 3, 4, 5, 6. In the back, we got 1, 2, 3, 4, 5, 6. So a total of 12 vertices. A prism is a polyhedron with 2 parallel congruent faces called bases connected by parallelogram bases. All right, so a prism is a polyhedron. What did we say a polyhedron was? It's a closed figure, flat surfaces, and the surfaces are polygons. So you see you got octagon up here, you got rectangles here. That's definitely a polyhedron, but what makes it a prism? It's a prism because it's got 2 congruent faces. In this case, they are octagons. See the octagon on the top and the bottom? Those are the bases. There's 2 of them for every prism. And they're connected by these other faces, these lateral faces, which are parallelograms. In this case, they're rectangles. A pyramid is a polyhedron that has a polygon base, in this case a hexagon, and 3 or more triangular faces that meet at a common vertex. All right, so you tell me, what makes a prism a prism? It's those 2 congruent, parallel polygons, 2 bases. And how about the pyramid? 1 polygon base and a common vertex. A cylinder is a solid with congruent, parallel, circular bases, and then a curved surface. Okay, it's not a polyhedron. Why? The surfaces are not flat, and they're not polygons. A cone is a solid with a circular base connected by a curved surface into a single vertex. Again, it's not a polyhedron. Why? This surface right here is not a polygon, and this surface right here is curved. Okay, you might want to note that a cylinder is like a prism, and a cone is like a pyramid. Okay, now I'm going to give you a little deep dive moment here. You don't need to know this, but it's kind of cool. If you thought about your prism and you allowed the number of lateral faces of the prism get bigger and bigger, right? We saw one that had bases that were octagons. What if you had bases that were decagons, and then 100 gons, then million gons, then 10 million gons, and eventually you let your number of lateral faces go to infinity? Then you would actually wind up with a cylinder. Likewise, if you took a pyramid, like a triangular base, and then a pyramid with a square base, and a pyramid with like an octagonal base, and you just keep going, so you have more and more and more and more sides. You have an infinite number of sides that eventually becomes a cone. Interesting. But a cylinder and a cone are not polyhedrons. A sphere is a set of points in space that are the same distance from the center point. A sphere has no faces, edges, or vertices. Definitely not a polyhedron. Okay. We have 2 polyhedrons, the prism and the pyramid. I'll remind you, the prism has 2 bases that are congruent, parallel polygons, and the pyramid has 1 polygon base and a common vertex. Then there's the cylinder, cone, and sphere. The prism and pyramid are polyhedrons, but the cylinder, cone, and sphere are not polyhedrons. So I want you to stop the video and ask yourself 2 questions. Why are the top figures polyhedrons? And why are the bottom figures not polyhedrons? All right, you can pause it now. All right, why are the top figures polyhedrons? Well, they have sides, vertices, edges, vertices, faces. All the faces are flat faces and they're polygons. Whereas the non-polyhedrons have faces that are not polygons, like circles, and they have curved surfaces, or have curved surfaces. All right, we have, again, the prism and the pyramid. What are the defining characteristics of the prism? What are the defining characteristics of the pyramid? Now's a great time to pause the video. All right, so what'd you come up with? A prism has 2 congruent polygon bases, and it has lateral faces that are parallelograms. Parallel congruent polygon bases and parallelogram connecting faces. How about the pyramid? Defining characteristics, polygon base and triangular faces with a common vertex, sometimes called an apex. All right, polyhedrons, or how we might call them polyhedra, are named by the shape of their bases. Look at these first 3 shapes. They're all prisms. Prisms always have a base and a second base that are congruent polygons. This is a pentagonal base. See that pentagon base is, and it's a prism, so this is pentagonal prism. This thing has a rectangular base and a rectangular base, 2 bases, so it's a rectangular prism. This one right here, what's the base? It's actually a triangle. Say, no, the base is a rectangle. Nope. This right here is a base, and that right here is a base. Those are the triangular bases, the congruent polygon bases, and then the other faces are all rectangles. So we call this prism triangular because its base is the two triangles. We call this a rectangular prism because its base are two rectangles, and a pentagonal prism because the bases are pentagons. These are pyramids. They each have one base and that common vertex, and the base here is a triangle, a rectangle, and a pentagon, hence the names. So you must learn the names of these polyhedra. Only you can memorize them. You must memorize them. How many bases do the prisms have? How many do the pyramids have? And what shape is the base of each of the 6 polyhedra? You want to pause the video and ask yourself the answers to those questions now. Okay. The prisms have 2 bases. The pyramids have 1 base. The triangular prism has the triangle bases. Rectangular prism, rectangle bases. Pentagonal prism, pentagonal bases. Triangular pyramid, triangle base. Rectangle base, pentagon base. All right. Determine whether each solid is a polyhedron. Then identify the solid. If it's a polyhedron, name the bases, faces, edges, and vertices. All right, what do we see? Polyhedron? Yes. It's got edges, vertices, polygon sides. It's definitely a polyhedron. What kind? Is it a prism or a pyramid? It's a prism. Got the 2 congruent bases on the top and the bottom. And what shape are those bases? They're rectangles. So this is what we call a rectangular prism. All right, we have identified it as a rectangular prism, so now we need to name the bases. There are 2 bases, the top and the bottom. So rectangle, MNOP, and RSTQ. Notice use the rectangle symbol. How about the faces? How many faces are there? 6, right? The 2 bases are faces, but also the 4 faces on the sides, lateral faces. So we should have 6 faces, RQPM, RSNM, and the tops and the bottoms, all the sides. How about the edges? The edges are what shape again? What is an edge? An edge is a line segment. So RM, MP, RQ. How many edges will there be? Well, there's 4 on the top, there's 4 on the bottom, and then 4 connecting edges. Therefore, 16 of them. Make sure you write the segment symbol above, like MN. And then finally, vertices. How many do you see? 8. 4 on the top, 4 on the bottom. And they're just points. Vertices are just points. So notice there's no special notation there. All right, let's try another. Determine whether each solid is a polyhedron. Is it a polyhedron? No, it's a what? It's a cylinder. What makes it a cylinder? 2 congruent circular bases connected by a curved surface. All right, how about this? Is it a polygon? Yes. Polyhedron? Yes or no? Yep, absolutely. Is it a pyramid or prism? Pyramid. What shape is the base? Triangular. So what do we call this thing? Triangular pyramid. All right. Name the bases. Well, how many bases are there? Just one. It's the triangle ABC. So you got to write triangle ABC. How many faces are there? There's 4. There's the base and the other 3 faces. They're all triangles. So we got like ADC, we got CDB, they got the base ABC. They're all triangles. How about the edges? Well, we got how many edges? 1, 2, 3, and then 4, 5, 6. The base plus 3 connectors to the base from the common vertex is 6. They're segments. And then finally, how many vertices? 4. Yeah, 4 vertices. Good. All right. Go ahead and try this one on your own and see how you do. All right, I'm back. This is a cone. It's not a polyhedron. It does not have polygon flat surfaces. How about this? You try this on your own, and I come back. All right, let's see how you did. This is a polyhedron. What type of polyhedron is it? Prism or pyramid? It's a prism because it's got 2 congruent faces, and they're both triangles. You'd say, I thought the base had to be in the bottom. No, it doesn't. The two congruent faces that are polygons, those are the bases. And then the lateral faces are going to be these rectangles. Okay, so we call this thing a triangular prism. Bases are going to be, again, the triangles. So it's triangle GHI and triangle JKL, makes using the triangle symbol. And the faces are those two bases plus this rectangle, and the bottom rectangle. So you'll notice 2 triangles and 3 rectangles, properly named. Edges, how many are there? 1, 2, 3, 4, 5, 6, and the connecting 3, that's 9. So you get 9 line segments. How many vertices? 3, and 3 is 6. 6 points. Vertices are points. A polyhedron is a regular polyhedron if all of its faces are regular, congruent polygons and all of the edges are congruent. There are 5 regular polyhedra. They are also called Platonic solids. All right, what makes a polyhedron a regular polyhedron? What do you think? Well, a polyhedron is a regular polyhedron if all of its faces are regular, congruent polygons, and all of its edges are congruent. Do you remember what a regular, congruent polygon is? A regular polygon, equiangular, equilateral, convex. So that means that these right here are equilateral triangles. These right here are equilateral quadrilaterals called squares, right? Equilateral triangles. So you see these various shapes that we've got going on. There are only 5 of these regular polyhedra. You can identify them by the number of sides they have. How many sides does this guy have? 4. So it's a tetrahedron. How many sides does this have? 6. So it's a hexahedron. How about this one? 8, octahedron. How many does this one have? 12 faces. You identify the number of faces. So this has 12 faces, this is a dodecahedron, and 20 faces, icosahedron. Just out of curiosity, do you remember when stuff like 12 and 20 showed up in this class? Yeah, on clocks, and where else? In degree measure. They may be ancient Sumerian, Babylonian customs that have been left over to our day, but these right here, the dodecahedron, icosahedron, exist, and they are one of only 5 regular polyhedron that exist that are called Platonic solids. So there is something to base 12 and base 20. That was a little aside. You didn't need to know that. All right, why are these called also Platonic solids? Because the famous philosopher, mathematician, and Plato, who lived in ancient Greece, along with our friends like Thales and Pythagoras and Euclid, same time, like 400s BC, you got Plato. He's a mathematician, a philosopher, and he was very excited about these 5 regular polyhedron. So they get the name Platonic solids. All right, some calculations you have to do in this chapter are calculations of surface area and volume. So this is a triangular prism. The surface area is a 2-dimensional measurement of the surface of a solid figure. The surface area of a polyhedron is the sum of the areas of each face. Right, how many faces do we have in this triangular prism? There's the 2 triangles and the 3 rectangles. So to get the surface area, I've got to add together 2 areas of triangles. A sub t means an area of a triangle, plus 3 a sub r's, which means areas of rectangles. Once again, look at the faces. How many are there? 5. How many triangles? 2. How many rectangles? 3. So to get the surface area, I get the area of the 3 rectangles, and then the area of the 2 triangles. 2 areas of triangles plus 3 areas of rectangles give you the surface area. That makes sense. A much cooler way to conceive of this is to do the following, and you need to know both sets of formulas and how it works. Surface area is still the area of 2 triangles. 2 a sub t means 2 areas of triangles. That's the base and the base, the 2 triangles. But then this right here is odd, right? P sub TL stands for perimeter of a triangle, P sub t, perimeter of a triangle times the length. This is the length. Okay. Perimeter of a triangle, what does that mean? That means this length of the outer portion of the triangle. If I multiply this red perimeter of the triangle times this length right here, here's what happens. The perimeter sweeps out all of the surface area of the rectangles. That's incredible. This strategy works for all prisms and cylinders, so you need to explain this strategy. I would pause this video and try to explain this strategy. Getting surface area of a prism. All right. Once again, there's the triangle in the front and the triangle in the back. If you get their areas, that's two areas of triangles, 2a sub t. But instead of calculating the area of these three rectangles, instead, I could take the perimeter of this triangle right here, perimeter of this base, multiply it times L, and that'll sweep out all of the surface area of the rectangles. Pretty cool, huh? I'm going to pause that or revisit that in the future. Volume is a three-dimensional measurement of the amount of space enclosed by a solid figure. Volume for a prism be the area of this triangle times this length. That'll work for triangular prism. Let's think about this. Does this make sense? Sure it does. Look at the area of the triangle. A sub t means area of a triangle. L means length. The area of the triangle is in red. If I multiply it times length, that's going to sweep out all the volume. The area sweeps out all the volume. The area of that triangle sweeps out all the volume of the solid. The strategy works for all prisms and cylinders. So I'll pause it now and think about how would you explain the strategy for finding the volume of a prism. All right, once again, see this triangle right here? This blue triangle? It's got area. It's two-dimensional. But if I multiply it times this length n, it sweeps out all the volume of the solid. Watch it sweep, the whole volume of the solid. All the stuff on the inside, volumes on the inside. Okay. Good. All right, so this right here is the formulas you need to know from this lesson. Formulas for three-dimensional figures. Just like in lesson 6, we had perimeter and area formulas for two-dimensional figures. In this chapter, we have surface area and volume formulas for three-dimensional figures. All right, let's see if we can make sense of some of these formulas. But before we do, let me tell you, you are responsible for memorizing this slide. You're responsible for memorizing all these formulas and knowing what they apply to. And that includes memorizing these words on the bottom. Because the way your book writes the formulas, you can't know what these things mean unless you've memorized these words. So memorize this whole page perfectly. All right, first let's make sense of the surface area of a prism. Surface area of this rectangular prism. What would you do? P times H. Well, what's P mean? Look down here. It says it means the perimeter of the base. Okay, here's a base. There's two bases for a prism. That's one of the bases. That's its perimeter. The distant length of that kind of outer distance. And multiply that perimeter times the height, we're going to sweep out all of this area, all of the surface area. The only thing that we won't have swept out is the area of the top base and the bottom base. That's why you have 2b. 2b is 2 times the area of the base. All right. Then, how about the volume of this guy? B times H. What's B? Area of the base. That's this, the area of the base. Times the height. That means the area of the base is going to sweep out everything in this prism and get you volume. Same thing works for a cylinder. 2 pi RH plus 2 pi R squared. Well, how am I going to get all this outer surface area, all this kind of surface area from this curved surface? Well, what's 2 pi R get me? 2 pi r gets me the circumference of this circle, the circumference of this base, and h, multiply it times h, and this circumference sweeps out all of that kind of wrapped around area. How about 2 pi r squared? What does pi r squared give me? Pi r squared gives me the area of this base, the area of this circle. Multiplying times 2 gets me the area of the top circle and the area of the bottom circle. So this part right here gets me the surface area of the toilet paper roll, and then the top cap and the bottom cap right here, 2 pi r squared. How about the volume? Pi r squared h. How does that work? Well, what's pi r squared? Volume of the circle times h means that all that area is going to be swept out through the entire height of the cylinder, and you're going to fill up all the volume. All right, folks, once again, you need to memorize the prism, rectangular, pyramid, cylinder, cone, sphere, the formulas you see here for surface area and volume, and what each of these terms mean, and only you can memorize them. All right, watch out. This is a cone. There's 2 heights. There's this height, which we call height, and this thing, which we call slant height. Height is perpendicular to the base, or we say height is orthogonal to the base. Slant height is not orthogonal to the base. It's kind of this height right here. So which is longer, the height or the slant height? Always the slant height. Can you see the right triangle that's embedded here? Leg, leg, hypotenuse. Clearly the hypotenuse is longer than either leg. All right, we need to find the surface area and volume of the square pyramid. How will we do that? First thing you have to do is memorize the formulas for the surface area and volume of the square pyramid and write them down. So you write down the formulas. Second thing you need to do is plug and chug. But in order to do that, you need to know what the letters mean. What does P mean? It means the perimeter of the base. How do you calculate the perimeter of the base? Well, it's a square pyramid. The base is a square. So the area of the base will be 6 squared. Oh, sorry. It'll be, not area of the base. I want to get the perimeter of the base. I apologize. The perimeter of the base. Okay, so it's a square, so you have 4 sixes. 6, 6, 6, 6. 4 sixes is 24. 6 times 4. Okay, the length, L is not length at all. From the last chart, it actually meant slant height. That's what your book says L means. So that's 5. That's a slant height is 5. All right, B. Your book says it means the area of the base, which is 6 squared or 36 for a square. Plug and chug, and you get 96 centimeters squared. Surface area is a measure of area, and area is always 2-dimensional. It's always an R2, 2-dimensional, so centimeters squared. You're asking, why is that? This shape looks 3-dimensional. Yes, but I could peel off each of the faces, and I could put each of those faces down on a plane, on the same plane for that. Some infinite plane, I slap down all the pieces, all the faces. And if you can do that, then really area must be an R2, not R3. It's 2-dimensional. How about volume? What's B stand for? Area of the base, which will be 36. What's H stand for? Orthogonal height, this height right here, the perpendicular height, which is 4. So what do we say? 48 cubic centimeters. Wow. 48 cubic centimeters. Volume is always in R3. It's 3-dimensional. It cannot be collapsed. The space inside this pyramid cannot be collapsed into a plate. It's 3-dimensional. It's in R3. All right. How about you? Can you do this one? Find the surface area and volume of the solid. Go ahead, give it a try. All right. Now back. Formula for surface area, formula for volume, where R is the radius of the circle and height is the height of the solid, height of the cylinder. See that? You're like, I thought height was always this way. No, height is from the base to the base. That's the height. If you're having trouble thinking about it, think about this right here as a cylinder that's knocked over on its side, the way you knock over a soda can. But you'd put it right side up, like you would a soda can. Great. Well, now the height's in the right place. So here's your radius, here's your height. Just plug and chug. 904.8 square feet per surface area. And I don't remember what this was, 2,000 and some odd cubic feet for volume. Again, surface area is area, and area is two-dimensional. You say, how could you possibly get two-dimensional area out of here? Well, the circle here and the circle here can be slapped on a plane. And this curved surface could be cut, like you'd cut a toilet paper roll, and then laid out flat into a rectangle, which would go in 2 dimensions. So area, R2. Volume, all the space inside the cylinder, no way. That's can only exist in 3 dimensions. So cubic feet for volume. All right, try the surface area and volume of the solid. Pause it and give it a shot. All right, we're coming back. Let's see how you did. Formula, pH plus 2B. Formula, pH. What does P stand for? Perimeter of the base. Base a rectangle, so 2 lengths plus 2 widths, which is 30.4. The height is just right here, 6. And what's B stand for? Area of the base. That's just length times width, or 52. So we got 286.4 square centimeters. How about the volume? What's B stand for? Volume of the base, area of the base. Area of the base. 5.2 times 10. And then height is just 6. All right. So we get 312 cubic centimeters. Last time I'm going to say it. Area, even surface area, is in R2. Volume is in R3. Hey, you have a quiz on Friday. What does this quiz cover? It covers everything on pages 58, 78. The formulas on page 58, 78. And the vocabulary on pages 56, 57, 76, and 77. But I've laid it all out for you here in this slide. And a PDF of this slide is attached to what's called Quiz 3 so that you can study. Additionally, if you were in class, I gave you a copy of this today, a hard copy, or yesterday, a hard copy. Okay, what do we have to memorize? Well, you have to know the perimeter and area equations for these two-dimensional shapes. Don't forget the key. You have to know what these words mean, these letters mean. That's from lesson 6. Lesson 8 today, these 5 three-dimensional figures, their surface area and volume, and what the words mean, what the symbols mean in terms of words. Also, you need to know what you would call like a 7-sided polygon, like heptagon, whatever. You have to know that. And then you have to know what you would call these 3-dimensional solids. They're either prisms or pyramids, and they're based on the bases, right? So triangular prism, rectangular prism, and so on and so forth. And then look at these guys, the 5 Platonic solids. You know, what is this one here called? A hexahedron. Yeah, very good. Lastly, on these pages, there's some vocabulary like polygon, side, vertex, convex, equilateral, angular, and regular polygon, and polyhedron, which look at this face edge vertices and a regular polyhedron. If I give you a definition of any of those terms, you should be able to write what it is. Okay. So if I say it's a 3-dimensional figure with flat faces that are polygons, it has faces, edges, and vertices, you'd say polyhedron. If I said, hey, it's a polygon that is convex, equiangular, and equilateral, you'd say, oh, that's a regular polygon. So you need to know everything on this page for the quiz on Friday. You're used to application quizzes. Your first 2 quizzes were application quizzes. This, however, is not an application quiz. It is a memorization quiz. Do you remember when you were a kid, you took your first division quiz Maybe you thought it was hard. Maybe you went home to mom and said, Mom, oh, I'm sad I did bad on my quiz. And so your mom went to your teacher and said, my student did bad on their division quiz. What's going on? And the teacher probably said, well, maybe they don't know their multiplication facts. And so mom asked you, do you know your multiplication facts? You said, of course I do. He said, what's 9 times 7? You said, I don't know. That's too hard. Okay, well, if you didn't know your multiplication facts, that made the division quiz really hard. But once you learn your multiplication facts, hey, division quizzes become quite easy. It's the same thing here. If you're going to be doing 2-dimensional and 3-dimensional geometry, you have to know the vocabulary and you have to know the formulas. These are math facts. Now, let me ask you this question. Who's going to learn the math facts for you? Me? Or do you have to learn it for yourself? Only you can learn math facts. So this is a memorization quiz, not an application quiz. And these are only formulas and vocabulary from lesson 6 and 8. Lessons 6 and 8. 2-dimensional figures and 3-dimensional figures. I would begin memorizing. All right, let's answer the following questions. What's a polyhedron? What's a prism? What's a pyramid? What's a cylinder? What's another name for a cube? What do you call a polyhedron with 2 parallel congruent triangular bases connected by rectangular faces? Finally, what's on your quiz on Thursday and Friday? I want to pause this and see how you do. All right, let's see how we did. A polyhedron, closed figure, flat faces, edges, vertices, faces. The faces are polygons. Prism, it's a polyhedron with 2 congruent polygon faces and parallelogram lateral faces. Pyramid, polygon base, common vertex at the top, triangular faces. Cylinder, congruent circular bases that are parallel, and a curved surface. Cube, another name for a cube. A cube will have how many sides? A cube will have 6 sides, so that sounds like a hexahedron. All right. What do you call a polyhedron with 2 parallel congruent triangular bases connected by rectangular faces? Well, that sounds like a prism. The triangles at the top and the bottom says triangular prism. Okay, what's on your quiz? Everything that was on that last slide from lesson 7 and lesson 8, formulas and vocab. You do have homework for Friday. It's 20 questions, but I have made it easy questions. These are all ones that link to the direct examples, none of the more deeply thought-provoking questions. So 20 problems, 3, 4, and 6 through 23 all. The key will be posted under the assignment in Lion's Den. Already is.